Okay, welcome to the second part of chapter 3. So, this is the second portion of chapter 3. Last time we talked about the different kinds of claims that we have. Specifically, we talked about frequency versus association versus causal claims. And under those, we talked about the difference between conceptual variables and operationalizations. There are two different kinds of operationalizations. They are measurements and manipulations. And the combination of a measurement with a measurement leads us to a correlational study, a manipulation, and a measurement is going to be an experiment. So why are we doing all this to begin with? Well, let's talk about errors. I know that you love type 1 and type 2 error because you practiced it so much before. We need to talk about the idea of type 1 versus type 2 error to make sure that you are totally clear about this. Now, you remember we said previously that we never say prove, right? We never say prove when we are looking at a study or specifically with a theory. We don't say prove. Now, part of the reason why is because what we're really trying to do is falsify, saying not that one thing causes the other, but that the null hypothesis is not supported, meaning that the null hypothesis, this thing doesn't cause that thing, is not supported. We can reject that null hypothesis. Okay, type 1 versus type 2 error. So let's go ahead and make our box. In real life, we actually don't know if something actually is causing it or not causing it. So we have real life here. We do not know if a null hypothesis is true or a null hypothesis is false. So this would be null true versus null false. Now, what does that mean? A null hypothesis means that one thing doesn't affect the other thing. So, for example, let's say that I have a hypothesis that my love potion causes people to be in love. My hypothesis is love potion causes love. The null hypothesis is love potion doesn't have anything to do with love. It's null, null effect. It's nothing, right? There's null. The null hypothesis would be that love potion doesn't work. It has no effect. If the null is true, then my love potion doesn't work. If the null is false, then my love potion does work. In real life, we are not sure, is it the love potion that's really causing the love, or is it something else? Is it a confound? Is it an alternative explanation? In real life, we don't actually know. We don't know, but we have a pretty high probability, remember that idea of p-value, a probability of something being the case or not being the case. So in real life, you don't actually know which column you're ever going to be in. We just don't know. We don't know. We have a good guess, but we don't know if the love potion really works. Over here, instead of real life, we have our conclusion. R meaning the researcher's conclusion. We can reject the null, or we can fail to reject. If I reject the null, remember the null is that nothing works, right? There's no effect, okay? If I reject that, then I'm saying the love potion worked. If I fail to reject, that means I don't have enough information here. I can't reject that null hypothesis. So failing to reject means the love potion does not work. Okay, the null hypothesis is love potion doesn't work. If I reject that, it means the love potion does work. If I fail to reject it, it means that the love potion doesn't work. We can't say that the love potion doesn't work. So what you're going on, let's say that I am an executive and boy, this love potion thing, this is going to be great. It's going to be really big for us. So let's say I go out there and I take this ad out that says, hey, guess what? My love potion, the Curtis love potion, it works, it really works. When in reality, it doesn't. It's snake oil, it doesn't do anything. Then what I've done is I've committed an error. Type 1 error. That's a 1. Type 1 error. A type 1 error is when you go out and say, hey, the null hypothesis is false, when in reality the null hypothesis is true. It's me going and rejecting the null, me going out there and saying, hey, this works. This love potion works. When the null is true, it really doesn't work. That would be a type 1 error. if I reject the null when the null is actually false, so I reject the null that says, hey, I'm saying that this really works, when in reality it really works, then I'm correct. There's no error there. That's where I am. However, if I fail to reject, okay, if I fail to reject, then the error is over here. This is a type 2 error. Up here, I've used Roman numerals to do type 1 and type 2. I don't really care. If you use Roman numerals or Arabic numerals, it doesn't matter to me, okay? This would be correct for that one. So if I go out there and say, you know what, I don't have enough evidence to say this really works, and in reality, it doesn't work, then I'm correct. But if I go out there and say, you know what, I don't have enough evidence to say that this works, when in reality it does work, then I've made a type 2 error. So here's the point. We, as researchers, we don't know how any of these different conceptual variables are actually affecting each other. But we do come to conclusions. We come to those conclusions based off of the probability, the factors that we've talked about before, the probability, and also the comparison group that we compare them to. We never really know which one is happening. One thing is for sure, though, we don't like to make these kinds of errors. And the specific kind of error that we don't like is probably the type 1, because that's us going out there and saying, hey, world, the love potion works, when in reality it doesn't. And we're going to look like fools when we get sued and when people tell us that we're wrong, etc. So that is a reminder of the type 1 versus type 2 errors. When we are looking at ideas of validity and etc., what we're trying to do is we're trying to get away from these errors. And the most specific one we're trying to get away from is type 1 error. We're trying to say, hey, this is really what's going on. We want the probability of us saying our conclusion being correct, being associated with what is actually happening in real life, even though we can never know for sure whether or not we've made a type 1 or type 2 error. That leads us to the validities. Validities are ways of testing your study to see if any of the conclusions are actually correct, to see whether or not we are really at risk of making one of these kinds of errors, of going out and saying that something's going on or not going on when it is going on or is not going on, right? Being wrong in our conclusions. So the validities are ways of testing what our conclusions are or are not going to be. So let's do an example with this. Let's say that I want to know whether or not my love potion causes a change in love, and whether or not that change in love then leads people to spend more money on Valentine's Day. All right? So here's what I've got. I've got two different concepts here. One is love, right? And the other is the amount of money spent, meaning the amount of gifts that I'm going to give, all right? So my hypothesis is that love causes people to spend more money. And let's say that I am going, because this is causal, I need to manipulate the amount of love. So what I do is I have one group that takes my potion and another group that does not, no potion. All right? That's how I'm going to manipulate love. And then after they've taken my potion or not taken my potion, I measure how much love, I assume how much money they spent on their partner. And the way that I do that is I ask them directly how much money. Let's talk about construct validity first. Construct, remember, a construct is the same as a conceptual variable. Construct validity is how well did you do in your operationalization of the conceptual variable. It's looking at the connection between the square and the circle in this diagram. It's saying, hey, did you manipulate what you claimed to manipulate, or did you measure what you claimed to measure? Does that make sense? So what it's saying is this. A question of construct validity looks at our manipulation. So remember, or our measurement. It looks at the operationalization. So here's our first operationalization. I had half the people take the love potion, half the people not take the potion, and I said, that's how I'm going to change love. Well, what if my potion doesn't work? What if my love potion doesn't work at all, right? If my love potion doesn't work, then I'm not actually changing the conceptual variable of love. I have low construct validity. Why? Because my operationalization is not effective with my conceptual variable. My love potion doesn't work, then I'm not manipulating what I claim to manipulate. That's low construct validity. The other form of construct validity that we have in this example is this. Does asking how much money did you spend on somebody, is that a really good measurement of how much you actually spend? Well, if you are out there saying, you know what, people lie all the time on how much money they actually spend on their partner, somebody's probably going to say that they spent a lot more than they really did. Then what you're saying is that this operationalization, this measurement, asking how much money you spent, is not a good way of measuring the concept. It's not a very good way of measuring that concept. It has poor construct validity. Construct validity is the question between the circle and the square, right? Whether that's a measurement or a manipulation. How well does the measure what it claims to measure? So how well does asking how much money you spent actually measure how much money you spent? Or how well does your manipulation manipulate what it claims to manipulate? How well does the love potion actually change love? That is the question of construct validity. We'll have basically an entire chapter just on construct validity. So that's coming back again. But construct validity is the operationalization compared to the conceptual variable, right? How well does your operationalization really operationalize the conceptual variable? How well does it measure it, or how well does it manipulate it? Next, statistical validity. Statistical validity just says, did you run the statistics in the way that you can actually come to the conclusion that you're supposed to come to? So let's say we did this study, and after we did this study, we decided that we were going to run, I'm trying to think of what would be a really poor one to do. We had one group that had a potion who took the love potion, the other group didn't have to take the potion, and so we decided that we were going to run a z-test. If we ran a z-test here, that would not be the right stat. That would not be the right statistic for this. And if we run that and came to our conclusions of rejecting or failing to reject the null hypothesis based off of incorrect statistic, we would have low statistical validity. Also, if you do the correct statistic, but then you interpret it incorrectly, then you have low statistical validity, right? You're not doing it right. So later on in the class, we're going to talk about our statistics, make sure we're doing our statistics in the correct way. All right. Internal validity. So internal validity, instead of looking at the connection between circles and squares, that's what construct validity does. Internal validity looks at the connection between circle and circle. So we're looking for internal validity. We're saying, hey, does love really cause the change in the money behavior? Or is it something else? Is it love? Is the hypothesized independent variable causing the change in the dependent variable? Or is something else causing the change in the dependent variable? Internal validity means internal to the experiment. Is it the independent variable that's actually causing the change in the dependent variable? So if I have half the people take a love potion and the other people take no love potion, and then I ask how much money they spend on each other, maybe what's going on, it's not love that's actually changing how much money people are spending. But let's say that my love potion is really nasty and makes people think they're going to die, and so it's actually death, right? It's actually death, the idea of death, that's causing the change in the money behavior, and not the idea of love, right? I sit there and say, oh, I'm going to die. I'm going to die. I better spend some more money on the people that I care about. That would be a problem with my internal validity. It's not my hypothesized independent variable love that's changing the dependent variable, how much money you spend. It's death, or thoughts of death, that change how much money I spend instead. That's internal validity. External validity means external to the study. That means do these conclusions, external validity is here. External validity means do the conclusions in this study apply to the real world, right? If I run this study in my lab, am I going to get the same conclusions outside of the lab in real life? So would people being in love actually cause a change in money, or is that really something that only happened because of the way I did things inside of my study? So external validity means, do the conclusions apply outside of the study's framework, right? Does the love really affect spending the money outside of a study environment in real life? Okay, here's what we're going to do. Let's go ahead and do an example using a very famous study, which is a Festinger and Carl Smith's cognitive dissonance study. I'm going to have you watch the video, and then I'm going to have you tell me about it, and we'll review it.